Okay. Are you all ready? Okay, sorry, I took a while. Oh, you? What's this? Wheat. It's a dessert? Dessert. Dessert. Can eat? Oh, big. Oh. I don't know. I just acting stupid. Okay. Yeah, anyone watched yesterday's video? Was it uploaded yet? Wait, where was I? Yesterday we did AFL 2, right? AFL 2. 2 and 3? 3 haven't started. Okay. Okay. Okay, so yeah. Someone kept it for you. It's a Sitong. Sitong character for the whole class. Those who are not here yesterday, I actually took a photo. I wanted to show you how sad it was, but I couldn't find it. Okay. Yesterday only got 16 people. Yeah, okay. So today we will try to aim until to finish 4.7. Okay? Can I will go through 4.3. I will go through 4.3 to 4.7. You keep your MacBook. Keep your MacBook in case. Keep your MacBook. Yeah. Then you can start part 5 notes first. Okay? I will go through it in a while. Okay. So yesterday there was 16 people. I recorded the lesson. Please go in and watch. Okay? Okay. So I start on part 5 first. Okay, no, I start on 4.3 first. Maybe I write down the answer, okay? I write down the answer. Is it okay? 4.3. Maybe I write down. Ariel, where do you stop? What question are you at? 4.3. Anyone at 4.2? Alanis, what question are you at? 4.3. Those who are fast, you can wait for me. If I practice that first. The actual question. Okay, those who finished, Jukai, I guess, Xavier, Chua, Yang Sihong, Tuan, Timothy, Braden, maybe your share answers. Okay, once okay, I'll start on part 5 for your. Huh? But it's for A only. Then B that I change to Global Max. Yeah. Okay. So I will try to write down local. Local. Okay, because in O-level schools they did not put the word local, they just put max. Yes, local. Yes. So local is basically, because strictly speaking, the word is local, it's not global. You can't prove that it is global. Okay? Can So just take note, the correct term should be a local max and a local mean. Okay? So some of you may be at 4 point. Some of you may be at thinking how to go through the second derivative test. Okay, so maybe I just want to say a few things. Okay, so let's say I ask Alanis this. Okay, Alanis, I draw a graph for you to see. Let's say the graph looks like that. Okay, so the graph looks like that, and I want to ask you, okay, here, what's the gradient at this point? Okay, can you give me an example of a gradient at this point? Okay, let me start it out for you. Okay, example, if you see the tangent here, right, steep, right? Let's say the gradient is -10. Over here, what would the gradient be? -7, correct? Okay. Over here, what would the gradient be, area? -5 or 5? -5, okay. Over here, area? -3. You see, I tell you before. Okay, here, -1. Over here, 0. Here, 1, 3, 5, 7, 10, right? Okay, so now, Alanis area, you all look at this. What do you notice about the gradient? What's the trend? What's the trend? Going up or going down? Increasing or decreasing? Is it getting bigger or getting smaller? From -10 to 10. Going up, right? Going up or down? Increasing or decreasing? Going up. Agree? Going up and all. So now you look at this graph. If I were to plot x versus gradient. Now, gradient is the y-axis, right? Gradient is like, for example, -10. With -7, -5, -3, -1. Gradient is 0. Gradient is 1. Gradient is 3. Gradient is 5. Gradient is 7. Look at this one. Can you see it's an outward sloping line? Am I right to say that the gradient is like dy dx? Dy dx. Okay, now, inception. What is the gradient of the gradient graph? How do I find the gradient of the gradient graph? Let's see how to use differentiation. How do I find the gradient of the gradient graph? Gradient is the same as dy dx, right? But if I want to find the gradient of the gradient, what would that be? Correct. Here, the gradient is none other than d2y dx squared. Now I ask you, Alanis area. This d2y dx squared, do you think positive or negative? Positive. Agree? Positive. So when this is positive, you can see a minimum point gives you a second derivative positive. Clear so far? So with this, right, I'm transiting you into this page. Okay? This is the second derivative test. Okay? I think all right. Are you here? You are at this page, right? Still at this page. This is the second derivative test. When the second derivative is positive, minimum point. Second derivative negative, maximum point. Okay? Can I? So if you don't know what to do, question 4.3, differentiate one time first. Find the stationary point. Differentiate once and find the stationary point. So now I go through question 4.4. Yeah, 4.4, we look at okay, those who are fast, Mitra, Timothy, they're all okay? Okay, okay, then do practice that while waiting for me. Okay, so sorry. Mitra, maybe you put the MacBook to the side. I scared spray onto your back. Hey. I foresee this will not be the last I'm shooting you. Okay, so x squared ln x, when you differentiate, that means slightly got product rule. Correct or not? So how come I never see product rule? Shouldn't it be a block rule? U prime B plus B prime. Okay, very good. Then you should have 2 ln x plus 3, I think, overall. Fine. 4.5. 4.5 answer is here. You just double check, can or not? The second one, is it this one? This one. You got the one, this one. No, you don't understand. You got the one on top. Oh, the one on top is the harder one. You got 0. Okay, what is your dy dx? Correct, right? So that one should be 1 and 1/5. So you should have this one, right? Okay, so when you have x equals to 1, do you use the second derivative? Huh? The nature. Don't know how to find the nature. You couldn't find for this one. Why? Is it because your second derivative is 0? So if the second derivative is 0, right? That means what's the result? The result is inconclusive. You understand? The second derivative is 0. What do you assume? Have I mentioned this? I can't remember. It's inconclusive. Okay, does it mean that second derivative is 0? Means that it is form of inflection? No. It's inconclusive. Have I given you a counter example? Yes, right. What's the counter example? X power 4. Very good. X power 4. Okay, Huh? Yes, then you use the first. Come again? No, the first cannot be 0. So the analogy that I gave for second derivative is like the 7-Eleven downstairs your house. It's okay. Second derivative is like the 7-Eleven downstairs your house. It's convenient, but it doesn't have everything. Huh? Yeah. So now okay. X power 4. Okay, so X power 4, right? Okay, it's an example. It's an example. This one came out before a few years ago, like in YEA. So they asked, like, can you give me an example of a question? Okay. Let's say if I talk about y equals to x power 4. Okay, you look at dy dx. What is dy dx is 4x power 3, right? Following the nature, since we need stationary point to find stationary point, we will probably take dy dx to 0, correct? Now, dy dx to 0, it means that we want 4x cubed to be 0. So if 4x cubed is 0, what will x be? It's also 0, right? But Evie also knows that if she look at x power 4, do you roughly know what the curve will look like? Okay, power 2, power 4, power 6, they are all the same shape. Yes, it's like this one, this kind of shape. Y equals to x power 2, power 4, power 6, they are all the same. They are all this shape. Okay, can I? So 0, 0 is over here. Evie, just look at the graph. Tell me 0, 0 is what kind of turning point? What kind of straight point? Minimum. But you see, using dy dx, if I find the second derivative, look at the second derivative, right? The second derivative differential more time is 12x squared. Second derivative, if I sub x equals to 0, it's 0. Correct? But you see, even though, oh dear. Where is it? So sorry. Okay, sorry. Okay, so sorry. So if the if the second derivative is 0, you can see it does not mean that it is a point of inflection. It's actually a minimum point. Okay? So that's why the answer is inconclusive. Okay, so what is this called? This is okay. If your stationary point of inflection will imply second derivative is 0. But second derivative 0 does not imply stationary point of inflection. Okay? In mathematics, we can also say the converse is not true. The converse is not true. Can I? Inflection will usually give 0. Because if inflection doesn't give 0, the second derivative is not positive, then it will. Okay, so yes, but so the inflection second derivative will give 0. But the converse is not true. When you get second derivative 0, doesn't mean it's an inflection. Why is it 0? What? Because how will I put it? Because if it's not 0, right? If it's positive, it's a minimum. If it's negative, it's a maximum. So by process of elimination, if it's not 0, it's going to show you something else. Right? Okay, but don't confuse about that. Don't confuse about that. Just know that if it's 0, it's confused. Okay? Yes. So one over square root is correct. Negative 1 over 2 is correct. But what's your second derivative? You haven't differentiate twice. Differentiate 多一次, differentiate one more time. Differentiate one more time. Okay, very good. Okay. If the if the dy dx does not change sign, okay, this is the first, okay, basically first derivative test. You go like that, like that, like that. You understand?
Yeah.
Correct or not? Yeah. But it doesn't, basically, as long as your second derivative is 0, you cannot conclude anything. You go back to first derivative test. First derivative test can tell you the result straight away. Second derivative cannot.
If you draw the graph of dy dx, then for this one, if it's increasing, then the gradient is positive, but if it's decreasing, it's negative. Then how do you draw the graph for dy dx of inflection?
How do I draw the graph of dy dx of inflection? Okay, so you see, okay, okay, I'll show you. Okay, I just show you a very simple graph. Y equals to x cubed. There's a point here, there's a point of inflection. Right? You differentiate this is 3x squared, right? Y equals to 3x squared will look like that. Oh? But 不重要啦, all this they are not life and death. Okay, can So now you have 12x minus 18, right? Okay, so here you equate to 0, you found 2 stationary points. Now then you need to find the y values. Now this you sub inside here. So you sub 1 in here. If it gives you negative, that means this is a maximum point. If it gives you positive, that means it's a minimum point. Clear so far? Okay. Okay, so now I think I will just, those who are still at part 4, don't need to stress. Go and change this. Still back. After school. Huh? Which one? You should. Okay. I also don't know. So it's like choosing the lesser evil. Okay. So part 5 is maxima minima. For the benefit of those who are ready, I will start very quickly. Maxima minima, just to let you know, in term 2 week 8, we are at term 2 week 6 now. Term 2 week 8, there will be a real life application and assessment. It will be on maximum minima. Okay? Real life task. 10%? I think around RAA. I think it's a group project. Okay, the grouping is the same group that you have at the start of the year. Okay? So derivatives and stationary points are useful in many everyday situations. You identify the variable and the quantity to be maximized, okay, as well as the quantity with respect to the variable. Okay, fair. So let's say today, today, okay, who wants to be a farmer? Let's say, for example, Joshua wants to be a farmer. Or Junkai. See, Junkai wants to be a farmer, or Joshua wants to be a farmer. Two of them come together. Okay, then after that, the question is, okay, maybe he goes to New Zealand. Government, okay, Joshua, okay, welcome you to my country, give you a land. The constraint is that you only have 100 meter of fence. Okay, I give you 100 meter of fence. You can build the land any way you want, but I want you to make money. So what will Joshua do? What's his concern? With the fence, what will he try to do? He will try to get what? The biggest area possible, right? Not Junkai, you want to get the biggest area possible, right? So let's draw it out. So Joshua and Junkai, they work together. Let's say X and Y. Okay, this is the area, the land and the breadth. So Junkai, you take a look. This is my your plot of land now. Okay, what you want to do is you want to maximize this area. Okay, now imagine Junkai is thinking maximize area. That means Junkai is thinking that probably there has to be some X or some Y. There's probably got to be some area that will give you the maximum area. Right now, it will give you the maximum area. So Joshua and Junkai, can I ask you, if you want the maximum area, this point, this value of X, that will give you the maximum area. What's so interesting about this point? Correct. Not only that, d2 dA dx equals 0, d2a dx square is negative. You understand? Can huh? So then after that, you go on. Okay, so Joshua, Junkai, now you Mitra. Who is at part 5? Will you mind listening? Will you mind listening to me? Okay, so now I look at this area. Okay, area is equal to x times y, right? How many variables do you see here? 2. Can I differentiate? Cannot. So after that, you look at this, right? Remember 2x plus 2y equals to 100. Correct? 2x plus 2y equals to 100. Can I say that x plus y is 50? Can I say that y is equal to 50 minus x? Since the max capacity is 100. So can I say that area is 50 minus x times x? Can I say that area is 50x minus x squared? So Joshua differentiate, which is 50 minus 2x. Bearing this in his mind, in his heart, he knows that it equates to 0. X equals to 25. d2a dx squared is actually just equals to negative 2, which is guaranteed to be less than 0. X is equals to 25. What does that tell you, guys, ladies and gentlemen, is that X is 25. What will Y be? 25. Now you know why overseas, right? Many of the plots of land are square. Because it gives you the maximum. With this, you know that with meter of fence, the biggest area you can enclose is a square. The area, the triangle that can enclose the biggest area is also equilateral triangle. Yeah. Okay, cannot. So this is a real life problem. Yeah. Yeah. So back to this question. Identify the variables, express the quantity in terms of one variable, differentiate, prove that it's dA dx equals 0. Finally, choose the first or second derivative test. Okay, I will now go through this. Okay, so you see, these are for self-reading. Have you all read through? So very quickly, you can see that number 1, identify the variable. S minimum means we want to differentiate the S dr equals 0. So we will need the function in terms of the radius. We need function in terms of the radius. I leave you to read. Differentiate. Equal to 0. Solve for R. Discussing number, I know. Use the second derivative test. Show that it gives you a minimum. Okay? That's the essence of the main strategy. Now you work at the question slowly. Question 5.1. Okay, I will come and take a look. Okay, yes.
I already found that
So you start E 1 over 5. One of them will give you 0. Yes. So when the second derivative is 0, the answer is inconclusive. Second derivative is 0 does not mean there is a point of inflection. So the example that I was telling them earlier is example like y equals to x power 4. Y equals to x power 4, right? You can see if I differentiate one time, 4x cubed. I equate to 0, I get this is my turning point. But you see when I sub in, right, I differentiate one more time, my second derivative is 0. But Isabel looks at the graph, she knows 0, 0 is not a inflection. It's a minimum point. Draw is one thing, or the test is you go back to the first derivative test. Okay? Do first derivative test. Can second derivative test is like the 7-Eleven downstairs your house. When you need to buy chocolate, yes, very convenient. But if you need to buy vegetables and eat, you cannot go to 7-Eleven. You must walk further. Right? You see everything. But you go. Yes.
So if one of them gives me 0, then I just don't use it.
It gives you 0. No, if you give you 0, right, for that point, you don't use. Yes, as long as it gives, okay, if it gives you 0, you don't use. Okay, like you can see, okay, when it's 1, right, it gives you 0. That's why you see I have no choice. I use the first derivative test. But when it's 1, but when it's 1/5, it's okay, right? It's a local max. Okay, so I use second derivative. It's easy. And Zoe looks at this. This one, okay lah, very easy to differentiate second time lah. I rather differentiate than sub. Cos. What's the graph for? What's the point of? Now, because what you are doing, right? Okay, you read the last sentence again. Read again. Minimizes the. But you are minimizing the. So that means which derivative? Which derivative should be there? dc, right? Your cos should be the numerator, ma. Right or not? Okay, so okay. So when I say minimize the cos, dimension is x, right? Cos, right? Now, Jun Kai, wouldn't you be the one to do this? Your cos and your x. You want to find out the x that gives you the lowest cos. Thus, can is can. That is okay. That is okay if both materials are of the same price. But if you look at your question, the top and bottom are of one price. The side is of another price. That's why it's not even. If they're of the same price, yes, you can throw away the cost and minimize the size. If you got no paper, I can pass you some paper later. Someone come again? Oh, are you all talking about topic part 5? Okay. The answer is yes, then what do you mean? 5.1, right? Oh wait, 1 second. Not there yet. Question 5.1, right? Max is 12.5 cm squared. When x is 5. Question 5.2, 10 cm by 10 cm by 20. Okay. Question 5.3. Part 1 is a show. Part 2, x equals to 6. Why is there a triangle there? Challenging question is. Oh, it's so challenging. Oh my days. Zoe, To answer your question, you can go to the annex and take a look. Question to page 39, you can go over there. Let's see something. Under appendix E. What Bermuda Triangle? Yeah. Yes, you do not need to care about denominator. Because by default, right, if when you have A over B equals to 0, B will never be 0. It's just A equals 0. Your denominator will never be 0. Or
Okay.
doesn't matter. Denominator will never be 0. So you don't even need to care about denominator. Yeah, Joshua. Plus minus square root 2.
This is so much space.
Why is there what? Why is there so much space? It's to give you some personal space. Yeah. Yes. You do 4.7 already, yeah. You still don't know how to start. Okay. So it's all right. Okay, so let me go through. Can I just see your 4.7? Wow, very good. Okay. So maybe let me just start on this. Okay. First of all, I just tell you this idea. Okay, I want to find maximum area. So Megan in her head, right? Is it's DA something. DA something. Megan in your head, Joshua in your head. You know that there's some A, there's probably some X. There's a graph where you're going to find that there's A possible. So you will need A in terms of X, correct? You need A in terms of X. What's the variable? The variable is area. Express the area in this case is X, right? The quantity is area, right? You want area as a function of X. Am I right? Triangle XYZ has a right angle as Z. So if I draw it out, there's a right angle as Z. Okay? Now YZ, XZ, YZ have a fixed total length of 10. This plus this equals to 10. Can or not? So let's put something as X. What do you want to be to be X? Can I say, who do you want to be the X? Since you want to be the X. You're falling asleep. You're falling asleep, Megan. Mitra. Are you falling asleep? Oh, no, I say, who is falling asleep? You say, yeah. Okay. So this is X, right? Well, then what would this be? What would Y say? If they have a fixed total length of X, then I call this X. Oh, YZ is X. Sorry. Then what would XZ be? Sweating a lot, right? Sweating a lot. Let me help you cool you down. Right? Then what is the area? Megan, what's the area? Very good. Okay, can you see? Area is half times X times 10 minus X. Step 2, differentiate. What do I do? Find dA dx. Okay? Step 3, take dA dx equals to 0. Solve. You should get X equals to 5. Okay? Step 4, check second derivative. Sub X equals to 5. You should have negative. Okay? Because you want to prove that second derivative is positive. E power negative X will never be 0. E power negative X will never be 0. So you remember, E power negative X is always having an asymptote. Okay, so you put reject because E power negative X is more than 0. One second. I help the message. Yeah. So you need to put Y in terms of X. Your variable. Okay. recall your days from part 5. What were the tricks that you use? Pythagoras? What else? Do you see a triangle in a triangle? You see something?
Similar triangle.
Can I? Okay, so yes, okay. Okay, so far so good. So this one you need to write down you sub in. The 2y dx square will become 0. Okay? Differentiate first. Okay, come back to this. This one, right? You need to do product rule for this. This one differentiate is 1. This one 2x. 2x times 1 over x. Not negative. 1 over x. Those who are fast, aim up to question 5.3. 1 over x. Okay, then this is minus 2. Minus 2. Give me a while, Zoe. Okay. Minus 2 plus 1. Your second derivative. Let me check. Two long x. Why is there a minus sign for us? Two minus sign, right? Because here it's plus 2x long x. You can take 2x to long x. Big long is 1 over x. It's not negative 1 over x. So it's plus 2, not minus 2. You guys stop a while, check on Ariel's progress. You help me make sure Ariel hit 4.7 by today. Yeah, you also can make sure he you also okay. So this one must change, right? This one must change. So this also must change, right? So now you sub this into this. Okay. What I'm asking you to do is what I'm showing on the screen as well. Okay, sub this one into here. You should have 2 long x plus 3. Sub inside here. You should get 2. Okay? Can finish what you start. You see, y over 5 is x over 12. Very good. You start it inside here.
Yeah, so I got. So you have recognize x, y, right? So y, I thought I got 5 over 5 over 12 x plus x. Now I need to make x 12 minus x. So y is 12 minus x.
Y is okay. Y is 12 minus x. No, okay. So this is x, right? This is y. Y is x over 12 is the same as this over this, right? This is 5 minus y over 5. This one is 5 minus y over 5, right? Right now. 5 minus y over 5. So what is y? Y over 5. Yeah, it's not y over 5. Yeah. So we choose the wrong. Okay. Okay, correct. So this one now, one of them, I think this value, second derivative test will screw up. So you will get 0. That means you cannot use second derivative. If the second derivative is 0, it's inconclusive. Okay? You can still use, but maybe you can use second derivative for this one. But this one you will do, then you will find out that there's something wrong. Yeah. Hey, Zoe, sorry. Why are you not wearing your skirt? Can you wear your skirt now? Wear first, if not, I don't talk to you. Who is not wearing their full tire? Then is wearing. How much do you sweat? You sweat a lot. Then you just change after the whole thing. Change. Give me sticky. Hey, waste over a towel and wipe yourself. Why don't you shower during recess? Then you have no time to eat. But you cannot be in this attire only. Right now. Huh? So you should change. Let's not see this again. Can? Let's not see this again. Can? Then you should. Then you know what's your job ideal for you? Become a PE teacher. So they can wear the. Provided they want. Okay, never mind. Sorry.
Like when you have like this kind of stuff, right? You just do this.
Yes.
It'll be easier to do this than do second derivative test, right?
I will do because this one looks very hard to differentiate the second time. So I will do first derivative. The power negative x cannot be 0 because it's an asymptote. Power negative x is power. So you just put reject. E power negative x is always more than 0. Right now, e power negative x will always be more than 0. We went through this type of scenario quite a few times. Right now, wherever we put this one, right, equals 0, right? No solution. It's, yes. You will never touch y 0. That's why we can straight throw away. We know that it will not give us any happiness. Throw away. You can do that. No, I see. Okay, you don't have to even worry about. Okay, so you don't even have to. Okay, so this one, you write it. This is a denominator. You don't even have to worry about it. You just need to take this. The numerator. 哦，不用嘛，你就管这个就可以了嘛。这个根本就不会给你零。This one, okay, this one 0, right? When a fraction is equal to 0, only the numerator can be 0. The denominator will never be 0. So this one straight away you can put reject. You don't even need to put this one. You can just put no solution. 就是你不用到这个地步了。I show you what I did. If you see, I straight away, yeah, look at this. I just jump straight away. Lazy man way. 都不用管下面，根本不用管那个下面。Okay? Because for a fraction, right, if it's equals to 0, if a over b equals to 0, you straight away can write down. This means that a is 0. You don't need to worry about the denominator because the denominator will never be 0. Okay, yes. Yes, it's but you can prove it. You can prove it. Yes. So what's the answer? Not easy. Now, you see, when x is less than 1 over k, right? When x is less than 1 over k, this will be positive. So this is positive, this is positive. Both are positive. That's why the dy dx. Okay, so that means what I'm trying to show you. Okay, if x is less than 1 over k, right? This part will be positive, this part will be positive for sure. Agree? Can because this point is from the stationary point. If x is more than 1 over k, this part will become negative. This part will become positive. Overall, it's still negative. So what am I trying to tell you? Now, Evie, when you read this, right, we read in English, but we think in math. We read in English, but we imagine a scenery in math. So what Zoe should see in front of her, is when x is 1 over k, Zoe will see this. When x is less than 1 over k, she sees them going up. When x is more than 1 over k, she sees them going down. So what am I doing? Now I'm 1 over k. Everybody to my left is climbing up towards me. It's a positive gradient. Everybody to my right is a negative gradient. This shows that I'm a global maximum. Okay, can
why do you need to do the Why do you need to why can't we just use secondary?
For which one? Because here we are not trying to show a local local max. We are trying to show a global max. In a way, not just it's more than the first derivative. That's it. Okay, so here, first derivative, what's the construct? The construct is we use a small neighborhood, correct? But here, I'm trying to show you at this stationary point where I am at, everybody to me on my left has a positive gradient. So I just you imagine I'm at here, everybody to my left has a positive gradient. That means they are all smaller than me. If anybody to my right, to my left has a negative gradient, that means somebody is dropping towards me. Everybody to my right has a negative gradient. This is trying to show to you that I am a global max. I'm a global max. So it is really bigger than the first derivative. You can see it's a extended version. If I show that someone to my left, for example, has a negative gradient. Okay, so you just imagine. If I show that, okay, for example, I'm at this point, someone to my left, for example, has a negative gradient. This is negative gradient. Can you see? Negative M. Then I'm no longer the global max. Okay? Yeah, but akan datang lah. Okay lah. You might not see a okay. Because that's for part A. Part A. Can see part A. I haven't do part B. Relax. Are you okay? What's bothering you? How to do? Sorry, how to do? 5.3. Part 1. Okay, part 1. Let me touch my pen. Wow, I go breath. Okay, now you see. Okay, remember when we differentiate, the idea is that you want to find the area, right? The area of the rectangle by right is x times y. Okay, we all know that by right the area it should be x times y. Now, I want to show it in terms of x. So y, using similar triangle, I can also do it this way. Y over 5 can be 12 minus x over x. So, Jun Kai, I show you this triangle. This is y. This is 12 minus x. I show you another triangle. The other triangle is 5 and 12. So y over 5 is the same as 12 minus x over 12. Y is the same as 5 over 12 of 12 minus x. So that's why my area, which is x times y, is x times 5 over 12, 12 minus x, which is 5 over 12x, 12 minus x. Should. Blue over pink. Yes. Yeah, can. 5.2. What? How to write the sandwich statement? Our final answer. Okay, so after you've done everything, right? Okay, you show already. Have you get A to be 12.5? After that, since second derivative, remember to write concluding statement. Very important. Okay, connector rate of change, differentiation question, write the concluding statement. Like primary PSLE question. 5.2. 5.2. Yeah, you just need to, okay, what do they ask for? They ask for the dimension, right? What are the dimension of the box? The dimension of the box is 10 by 10 by 20. Okay? The square base is 10 by 10, the height is 20 cm. Okay? Can I? Okay. No, I want to help the rest first. Okay. We'll watch the video. Okay. So from here, yeah. Okay. So, yeah, it's here. Okay. From here, very simple. When you look at 1 over k, right? Okay. Everybody on the left, the gradient is positive. Everybody on the right, the gradient is negative. Okay, because your dy dx looks like this. Can you see? Now, everybody on the left of this, right, the gradient is positive. When x is less than 1 over k, when x is less than 1 over k, okay, when x is less than 1 over k, you can see that this one is positive. Can? Once again, when x is more than 1 over k, this is it. What am I trying to tell you? Now, see how you see, you imagine a picture. The picture goes like that. Okay, when x is at 1 over k, right? This is the graph. Everybody on the left has a positive gradient. Can you see? Everybody on the left has a positive gradient. Everybody on the right has a negative gradient. Maybe I'm trying to tell you I'm the biggest really. I'm the biggest guy. Oh, I'm the biggest. Okay. Now, so looking at this, yeah, you can try to prove that it's a global maximum. How do I show that I can upgrade from a local max to a global max? Is that if I show that everybody on my left is positive gradient, everybody on my right is negative gradient, then I'm the biggest. 可以吗？可以啊。Yes, 微笑。5.2. What's your function? Is your function this? Correct, correct. Why got x4? Shouldn't it be x cubed? Bro, check again. Can you check your derivative? Do you differentiate correctly? Okay, can you check your derivative is the same? Okay, so can you your t the same?
No, I got
Don't say then you differentiate this one, right? This one, this is x, not x squared. This one is x. Oh, fair enough. It's x. This one is x, not x squared. This one is x. Because you must be able to times 4 sides. Times x, that's it. Oh, okay, okay. Okay. So I stop here. This one is part 1, increasing, so you want the gradient to be more than 0. Yeah. Okay. So when can I go through the assignment? Oh yeah, keep thinking to this Friday. Tomorrow, okay?